I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here is extended review of quadratic relations. You will learn finite difference, graphing, and solving equations in such a way that you can solve equations for grade 11 and 12 also. Our approach, engaging minds, helps to consolidate learnings, relate applications, apply concepts, and bridge the gap. That is creative thinking and problem solving. Gift of education. Join Anil Kumar classes. I can be part of your success story, build strong foundation, ensure bright future. You can send an email and begin with these classes. Let us now enjoy a session with Rohan. Hi Rohan, how are you doing?
I'm good, sir. How are you?
Very good, very good. So today, what do you want to do?
Sir, I would like to do a review on quadratics for today.
Very good. So final exams are coming in. When is your final exam?
So my final exams is going to be during this week at around Thursday.
Okay.
Thursday.
Okay. So last few classes, let's review quadratics today, and then tomorrow we'll review rest of the curriculum, whatever is covered in grade 10 for you. Is it okay?
Okay, sir.
Feel free to ask me any questions wherever you want to, right? So, but today's class, I'll ask you different types of questions so that we review quadratics properly. Is it okay?
Okay, sir.
Let me share with you a whiteboard. So we'll just start with a blank screen and see how it goes. Okay, so we are trying to review quadratic functions, right? MPM2D. Great. Right. So to begin with, we always find the finite difference. You remember finite difference?
Yes, sir.
My question on finite difference to you is, if y equals to, let us say, 4x squared plus 2x minus 1, which finite difference will be constant?
Which finite difference would be constant, sir? Like
Yeah.
as if we were to have linear equation?
This is quadratic equation. Which finite difference will be constant? Tell me. A and B. What will be its value? So if it is a quadratic equation and you want to find the finite difference, then which finite difference will be constant?
It would be the second.
Can't hear you. The internet problem.
Oh, it would be the second finite difference. Yes,
That
sir.
is perfectly fine. Second finite difference. Let me say this is difference and we are writing a second. Is that okay?
Okay,
Now
sir.
tell me, for the given equation, y equals to 4x squared plus 2x minus 1, what is going to be the value of second finite difference?
Okay, sir. So if x is independent, y is dependent on x. So if we were
Second
to
finite
take,
difference value is what? Tell me.
so is it okay if I can write down, sir, and then after I
Sure,
tell
sure,
you?
sure. Write
Okay.
down, calculate, then let me know. How will you figure it out?
So one way is substituting in. So if I took 5 points like -2, -1, 0, 1, and 2, and then input into the equation, I could get, so let's
Okay,
see,
do it and tell me.
16 minus 4 is 12.
Do you get your answer? You can use calculator. And I can tell you answer without calculating anything. And I'll tell you the trick. Yes. You should get 8 as your answer.
Yeah, that's what I got, sir.
Now, see, that is what review is. We are always learning new concepts. Is that clear to you? Something
Yes,
more
sir.
than what you know, right? Because I've been teaching you, I know exactly what you know and what you don't know. So this is what is required in grade 11. So do you remember we talked about sketching quadratic functions and we talked about the step 1357,
Oh yeah, the step pattern, sir.
and that should be multiplied by a when you're sketching the graph, correct?
Yeah.
If that is a step pattern, then what this is the first difference. This step pattern is first difference. Do you understand? Right?
Yes, sir.
The second difference will be what? 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is 2. Is it okay?
Yeah. And then you
Because
multiply all of them, right?
by 4, because here we have 4 here as the leading coefficient. So you get a constant difference of 8. Is that clear to you?
Oh yes, sir.
So from where you already knew all this, right? We are just trying to connect. You get the idea?
Yeah.
That is the beauty of learning, with me especially. Okay, so let me clear this and get to the next page. So we found what? That if I have equation y equals to ax squared plus bx plus c, in that case, second finite difference is constant, and its value is 2a. 2 times a. Do you get the idea?
Yes, sir.
So how do you relate it? So we have a relation, we relate it, or you can say we can connect it with step pattern, which for a quadratic function is 1, 3, 5, 7, and so on times a. You get the idea.
Yes, sir.
And you know this step pattern. So the difference here, step pattern basically, as you know, is first difference. Second difference is 2, right?
Yeah.
And times a will be what? 2a. So that is how we connect and find the result. In
Okay,
grade
sir.
12, you will learn this formula that the difference, nth difference, if we have a talking about polynomials, it could be of degree n, right?
Yeah.
The nth difference is how much? It is equal to the n factorial times a.
Okay.
N factorial times. So if I have a cubic equation, then the third difference is going to be constant, correct?
Yeah.
And n factorial, do you understand what is n factorial?
No, sir, I don't understand that part.
Yes, n factorial is product of numbers from 1 to n. 1 times, 2 times, 3 times, 4 times, so n.
Also, it's basically like infinity, sir, right?
No, up
Infinite
to n.
numbers.
Product up to n. So let me just pick this up now in the next. Let's extend our learnings, right?
Okay, sir.
So what we have learned today is we can actually find finite difference, rather constant finite difference for any polynomial with simple formula. Formula is that the constant finite difference polynomial of degree n is a times n factorial. where n factorial is product of numbers up to n, 1 times, 2 times, 3 times, so on till n. You get the idea?
Yes, sir.
So I'm going to illustrate this with an example, simple example. So let me illustrate. So let's take y equals to x cubed, okay?
Okay, sir.
So we know that third finite difference is constant, right?
Yes, sir.
Because cubic equation. And what should be the value? Here
For
a is 1, right? A equals to 1, right? So it'll
yes, sir.
be 1 times 3 factorial, which is 1 times, what is 3 factorial? 3 times 2 times 1, which is 6. Do you see that?
Six. Yes, sir.
Now let's verify our result.
Yes, sir. I also started joining from my computer, so I'm gonna
Okay.
get back on my computer.
Okay.
Yes, sir. Yes, sir.
So you're back. Very good.
Yeah.
Let's verify the result. So I'm going to take this example, y equals to x squared. So let me calculate now, just to verify. So if I take different values of x, let us take x values as simple values 0, 1, 2, 3, let's say. Then the y values, let's say 4 ohms. Then the y value, which is equals to x cube, will be what? 0 cube is 0, 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, correct?
Yes, sir.
Let us find out the first finite difference. So what do you get? Can you calculate and tell me the values?
So it will be 1, 7, 19, and 37.
Let's find the second difference.
It
What do
would
you
be
get?
6, 12, and then 37, 18. Then 6, and
Put
then
18 here.
6.
18. So third difference.
I got 6, sir.
You see the point, which is we calculate. You get the idea from the formula?
Yes, sir.
You can
Okay, so
see.
basically for what you did, sir, right, was you just input your A value and then how
N
much it was
factorial.
cubed, right, sir?
Yes.
The factor. Okay.
Do you understand? If my equation
Yes.
is y equals to 2x to the power of 4 minus 3x squared, then the constant difference will be the fourth, and the value will be 2 times 4 factorial. Is that clear to you?
Yes, sir.
So that is how easily we can relate finite difference with the leading coefficient. Do you understand? So that is a
Oh,
relation
yes.
which you learn.
So, sir, when you have more than one exponent, you go with a bigger exponent, right, sir?
Leading coefficient, yes. So leading coefficient is the coefficient with term of highest degree. Is that clear to you?
Yes, sir.
Okay, so that is new learning. Let's move forward from here. So from this, we'll now get into how do we graph quadratic functions. Okay. So three methods you have learned in this unit. One, you learn when you have vertex form, correct?
Yes, sir.
Let's take an example. Y equals 2 times x minus 3 squared, let's say plus 1. So in this case, how will you graph it?
So we already know our vertex point. So it would be 3 and 1 because it's H and K. So we can start from there. And another thing is that we also notice that the graph is going to be vertically stretched by a factor of 2. So we can just use the step pattern and multiply everything by 2.
And we know it will open up, right?
Yes, sir.
Because stretch factor is positive, it will open up. So simple way of doing it is, I'm not drawing the graph paper, but we can just locate the vertex first, which is 3, 1, correct? And next time, we have to go 1 unit right, and how much up?
1 up.
2 times 1,
Or
2
2
up.
times up.
You get the point? So 1
Yes,
unit
sir.
right will be 4, 2 up will be 3. Do you see that coordinate?
Yeah.
Next time, we are going to go 1 unit to the right, and how much up?
3
2
up.
times 3 is
6 up,
6.
6.
So this will be 5 and 6 plus 3, 9. You get the idea.
Yes, sir.
And from the symmetry, we get the other side, right?
Yes, sir.
Because we know the axis of symmetry is x equals to 3. Is that clear to you?
Yes, sir.
The graph is done. You get the idea. How efficiently we are sketching the graph without any difficulty, right?
Yeah.
So we use the equation of axis of symmetry, which in this case is x equals to 3, right?
Yes,
You
sir.
know, and then we can sketch the graph. So that is using the vertex form. Is this clear to you?
Yeah.
Next, intercept form. So in intercept form, we give you x intercepts. We say y equals to, let us say, x times x plus 4. How will you sketch this graph?
So what I will do is I'll first locate my x-intercept, which is -4.
Also 0. Many times student will miss this. So there are two x-intercepts, one at 0 and one at -4. And then next thing.
And then what I'll do is I'll locate my axis of symmetry.
Which is
So
add them
r
and divide
plus
by
s, which is just -2 in this case.
-2. So we have axis symmetry at -2. So let us say we have this axis of symmetry. This is x equals to -2. Then,
What
so
I
it
will
opens up, so you have a minimum, right?
yes,
So plug in -2, so you get -2 times -2 plus 4, which is equal to what? -4, right?
yes, sir.
So -4. So we know that -4 is somewhere here. Let's say this is -4. Is that clear?
Yes, sir.
And of course, you can still draw the graph using these points. Is that clear to you?
Yes, sir.
If you want, you can calculate 1 or 2 more points. But this is simple. You get the idea.
Yes, sir.
Let me take another example based on this. And let me take this as minus half x plus 3 times x minus 5. Tell me, how will you sketch this graph?
So first I'll locate the x-intercepts. So one is at -3 and the other is at 5.
Yes,
Then what I'll do is I'll calculate axis of symmetry. So in this case, -3 plus 5. It would be 1, sir, as our axis of symmetry.
correct.
And then from there, I can plug it into x plus 3 and x minus 5 to get my max value, considering that it is opening downwards.
Perfect.
So if it would be 4 and -4, so half multiplied by 4 would be -2 multiplied by -4, -8.
Correct. And so you get your graph where you know that the axis is at +1 this time. And it has two x-intercepts, one at 3 and one at -3. So you just graph it, right?
Yes, sir.
And we
And
know
you can
this
also
point.
find for the y-intercept as well, right?
Very good job. It is good to always mention y-intercept. Yes, sir. So y-intercept is what? Tell me the value.
So
Plug
x would
x0,
be
right?
0, so then just should be 3 and -5.
So positive 15 divided by 2, which is 7.5. Is that okay?
Yes, sir.
So you have the maximum value of 8, y-intercept of 7.5, 2x-intercepts -3 and 5. axis symmetry x equals to 1. This is 5 parameters which we have already given on the particular graph. And also we know the end behavior when x approaches negative infinity, y approaches negative infinity. When x approaches positive infinity, y approaches negative infinity. Are you clear about end behavior?
No, sir. I'm not. I don't understand that part.
Correct.
Well,
This is another extended. Let's go for extended now. So the term end behavior. End behavior really means what happens to the curve when x is a very large value, we say positive infinity, or when x is a very large value but negative. So in our graph, which is kind of going up, right?
yes, sir.
You could have two types of graphs, correct? So in the graph which is going up, we know that the y value is approaching positive infinity, but it's going down, y value is approaching negative infinity. Do you see that?
Yeah.
So that is the end behavior. So if the value of a is greater than 0, means positive, it goes up. And if the value of a is less than 0, it comes down and definitely has a maximum. And in the previous case, it has a minimum. Do you understand?
Yeah.
These are the turning points, correct? Is this clear end behavior now to you?
Yes, sir. So when the graph is opening up, we can say that x would be positive infinity and y would be positive infinity.
Yes. When x approaches, we use the word when x
Approaches.
approaches.
Okay. And that depends where the graph is opening, right, sir?
That really depends on the a value. If a is positive, it opens up, correct?
Okay.
Another very important term is increasing decreasing interval.
So is it like the domain and range, sir?
That's another value, but increasing decreasing interval. Now MCR3U, when you begin with, these are the terms which they will start working on, including domain range. So let's talk about this, right? So if I have an equation which is y equals to 2x plus 3 whole square minus 7. In that case, we know that the vertex is minus 3 and minus 7, correct?
Yes, sir.
Now, the graph opens up. And therefore, I could sketch a rough graph, which is kind of like this. Is that clear to you?
Yeah.
With my vertex, which is minus 3, minus 7, correct? Now, from this graph, can you tell me what is the increasing interval?
It would be 2, sir.
No, interval is a range of values.
Oh, okay.
And what is the decreasing interval?
So like greater than or equal to 7.
Yes, not 7, but the x value. So whenever we talk about interval, we see left to right. Is it okay?
Okay, sir.
So you say this is increasing on this side, on the right side of minus 3. So interval for increase is x is greater than minus 3. And decreasing interval is x is less than minus 3. Does it make sense to you? So simple.
Okay, sir.
So it is decreasing from minus infinity to minus 3. And from minus 3 to x values higher than that, it is increasing. Correct? So it decreases and then increases. And therefore, we know this is a turning point, right?
Yeah, so we look at it from left to right, basically, when doing it, right, sir?
Correct. Good. Now let's talk about domain range, another very important characteristics, and then we'll move on to the next. Okay, so if I have a parabola, let us say which is 2x minus 3 whole square minus 7. Now we know it opens up, correct?
Yes, sir.
And the vertex for this is 3 and minus 7, correct? As far as domain of parabola is, does it have any restrictions on x value? You can put any x value, right?
Yes,
You
sir.
say x belongs to real numbers, right? And we write this in curly brackets, means set of. But as far as the range is concerned, we know y belongs to real numbers. However, y value is always greater than equal to -7. It is never less than -7, correct?
Yeah.
Because we know this is positive, right? So -7 plus something. -7 plus something will be greater than -7. So that is how you could get domain and range of a quadratic equation.
Just by simply looking at its vertex, right, sir?
Sometimes you have to work on it. Let me give you another equation. So y equals to 2x minus, let's say 1, times x plus, let's say 5. Can you find domain and range of this function?
Yes, sir.
Tell me.
So to find domain, what we can do is we can locate the, like, basically our axis of symmetry. From
Domain
there,
is all real numbers, so do not think about it. Domain is all real numbers for parabola, no restriction, correct?
oh
Easy.
no, yeah.
For range, tell me now.
Okay, for range, so if it's -5 and it's 1, it would be -2 as the axis of symmetry. So then we can just put it into x minus 1 and x plus 5. So that would be -3 and 3. That's -9, -18.
So this is a parabola which opens up, right? So now you find the vertex. It was not clear from the intercept form. So now you know that the range is what? So y belongs to real numbers where y is greater than or equal to -18.
-18.
Very good job. So that is how we work with quadratic relations. Very good. Now let's see how to solve quadratic relations. We can use the word functions also. Remember in grade 11, you're doing the course MCR3U, where the first chapter is functions. You understand?
Yes, sir.
And quadratic functions and linear functions are the very first functions you are going to learn. So all this will be very handy when you just enter next grade within a couple of months. Okay, how do you solve quadratic equations? Now, one of the solutions is intercept form. As you know, if I say y equals to half x plus 5 whole square. Now, what is the solution of this equation?
So, like distributive property in FOIL, sir?
No, you should not do it. Solution means, what is the meaning of solution? Find value of x for which y equals to 0. This is the meaning of solution. You understand?
Okay, sir. Is it okay if I can write that down?
Please.
So fine. So we just have to, it's basically like intercept, right, sir? So if y is 0, then we can find x's value.
You're right. Is as x intercepts. Now, let me tell you a word of caution. When we say x-intercept, we are working in the domain of real numbers.
Okay, sir.
So I'll tell you what is the other domain, which is not a domain of real numbers. So we'll talk about that. Not real. Numbers will bring us to complex numbers. So we'll talk about that also today. Is it okay?
Okay, sir.
Okay. So can you tell me the solution of this equation? Well, this is plus 5. I copied it. X plus 5, right? What is the solution of this equation?
So if y is 0, then it would be half of x minus 5 multiplied x minus 5.
So only x value of minus 5 will give us a 0, correct?
Yes, sir.
Even if you sketch this graph, you can figure this out, right?
Yeah.
At minus 5, it will have a 0, right? And so that becomes a 0 and the solution. Is that clear to you?
Yes, sir.
And this value is 2.5, as you can calculate, half of 5. Oh, sorry, 25 by, sorry, 25 by 2, right?
Oh, yeah.
5 squared. Let's erase this. Now, solve equation. Let me give you another equation, which is this time y equals to, that is the 2x minus 3 whole square. And let me write this value as 8 minus 8. Okay, let's write plus 8 here and minus 2 here. Can you solve this equation? Tell me the answer, please.
So the equation y is equal to 2x minus 3 whole square plus 8. Oh, minus 2. Yes, sir.
Tell me what is the solution and how will you find the solution of this equation?
Minus 3 whole square. So we already know the vertex is 3 and 8. So what we can do
You have to
is
find the solution. So bring 8 to the next left side, rearrange. Now divide by minus 2. So we have 4 equals to x minus 3 whole square. Is this clear to you?
yes, sir.
So basically, solving really means isolate x. You understand?
Okay, sir.
Now tell me next step. 4 is equals to x minus 3 whole square. What is the value of x?
So if we were to like solve it, so then it'll be x squared minus 6x
No,
plus 9.
do not. So caution. Open bracket. Is it okay?
Okay, sir.
That will be a huge mistake. Square root both sides. What you should do? Square root both sides. When you do square roots both sides, what will you get? Tell me.
So square root of 4 and square root of x minus 3 whole square. 2 equals to x minus 3.
No, wrong answer. What is the mistake? Tell me. Whenever you square root, do plus and minus. Because minus 2 square is also 4, correct?
Oh, yeah.
And therefore, now you get your answer. There are a couple of mistakes which you could still do, right? X is equal to 3 plus and minus 2. And that gives you two solutions, which is 5 and 1.
And 1.
So that is how you're going to solve a quadratic equation given in vertex form. Is that clear to you?
Yes, sir.
Clear. Let me take another example since you had some difficulty here. Minus half x plus 3 whole square plus, let's say, the value as 8. Tell me, how will you solve this equation?
So what I'll first do is I'll bring 8 to the other side. So it'll be
First
negative
write
8.
0. Solve means y equals to 0. And now bring 8 to the other side. Multiply by 2
Then
minus.
so that'll be 16 equals x plus 3 whole square. Square root 16 plus minus equals x plus 3. So I got x as I got x as 7 and 1.
Negative. -7 and +1, correct?
But how did we get -3, sir?
Square root,
Is it like
we have x plus 3. When it goes to the other side, it becomes -3, right?
okay?
So be careful.
Oh, I see what you mean, sir. What you did was you just brought it that way. You made x on its own.
Correct. Now that brings me to a very important question, which I take up with grade 12 students. In both the solutions, so I square rooted and I got the answer. You get the idea with plus and minus, okay?
Yeah.
Simply because you do not know about another function which you'll learn later in grade 12. So the question for you is, this is bonus question at this stage. What is square root of x squared? What is square root of x squared? Tell me.
Square root of x squared, sir. Wouldn't both square root and square cancel out? So wouldn't it become x, sir?
Wrong answer. Let me tell you why. If x equals to 7, correct?
Yes, sir.
Then we write 7 square root, which is square root 49, and which is 7, correct? So
Yeah.
it is equal to x, right? 7 equals to x. How about when x is -7? Then you write -7 square, correct? Still you get 49, but what is your answer? +7, not -7.
Okay.
So what is square root of x squared? Tell me now.
Then it would just be. So if we consider it as negative, it would still be positive.
Yes, so we have a function for that, and the function is called absolute value of x. So it is absolute value of always positive. Is that clear to you?
Yes, sir.
Always positive. So it is absolute value of x, which is square root of x squared. And what we were doing is we were actually making the left side plus and minus, because it could be +7 or -7. We were not sure of. But strictly speaking, we should have done the right side as absolute value of x. But we are not doing it since in grade 10, you don't know what absolute function is, correct?
Okay, sir. So when doing it, it would just be square root of x always equals
Absolute
to
value of
absolute value of x. And this is when we don't know what x's value is, right, sir?
yeah, of course. X could be anything, right?
Yes,
But
sir.
even if you know, you now know the answer, right? For example, let me do one question once again. Simple one I'll take, right? X minus, let's say I wrote 7 square, right? And let me write this as minus. Let's keep it simple, 9. Now let's solve this equation once again. Can you solve this equation?
So x minus 7 square minus 9. So reserve equals to x minus 7 whole square minus 9 equals to x minus 7 whole square.
Now see what I'm doing. I'm doing square root on both the sides.
Yes, sir.
So what is square root of 9?
Plus and minus 3.
No, I'm not written plus and minus. See the beauty. Actually speaking, it is square root of 9 is 3. What is square root of x minus 7 whole square? It is absolute value of x minus 7. You understand?
So, okay, so basically what you did, sir, is you just canceled out each other, making it x minus 7.
Absolutely, because last time we saw it could be, plus or minus. So normally in grade 10 or 11, when we have not learned absolute function, we write plus and minus 3 on the other side just to get the right answer. But strictly speaking, this is the right way, correct way. Now we can solve it. When I say absolute value of x minus 7 is equal to 3, that means two things. That x minus 7 could be positive 3 or x minus 7 could be negative 3. Do you see that?
Okay, so it's basically like what we were doing before when you did the
Before.
plus and minus for square root. Okay.
Yes. So you are always getting the right answer because actually you're doing the right thing. However, the method has a flaw. Now it is correct. You get the idea.
Yes, sir.
It's very important to understand that square root of x squared is actually equals to absolute value of x. So how many new things have we learned today?
So one was this method, absolute value. The other one was how I can solve equations, like isolating for x and never opening the brackets when doing it.
Yeah.
And then also another thing that I learned was, I can't remember the name, but it was used to help calculate the second finite difference
Perfect.
or third finite difference
Very
with.
good. Let me just take up the last value, that is analyze. You can write Z also. Analyze discriminant. You remember this? If
Yes,
I
sir.
give you the equation y equals to 2x squared plus, let's say, 3x minus 7, what is the answer? You use a quadratic formula, right? You
Yeah.
say, well, x is equals to minus b plus minus square root of b square minus 4ac divided by 2a. Substitute the values. A, B, C, you know, right? So A is
Yeah.
2 here, B is plus 3, and C is minus 7.
Minus
You
7.
substitute, you get minus 3 plus minus square root of, so we'll write 3 square, right? And then, okay, uh, that is b square minus 4 times a and minus 7, correct?
Yeah.
Over 2 times a over just 2 times 2. Can you calculate? Tell me the answer.
So that would be.
Yes, approximately you got two answers here.
Yes, sir.
Perfect. So you get these two solutions over here. However, there could be a situation which is kind of like this. Let's take another example. Y equals to 2x squared plus x plus 1. Okay. Now, in this particular case, let's say plus 4. Okay. Now, in this particular case, if I apply the formula and find what is the value of x, you say minus 1 plus minus square of 1 square minus 4ac, 4 times 2 times 4, right?
Yes, sir.
Over twice 2, right? And you get minus 1 plus minus square root of 1 minus 32, correct?
Yeah.
Over 4, which is minus 1 plus minus square root of minus
That's
31
31.
over 4, right? So what do you say at this stage?
It would be non-real numbers.
No real solution, right?
Yeah, because if you were to plug it into the calculator, it would say error.
So you will learn later that this has a solution when we have complex numbers.
Okay, sir.
In complex numbers, problem here is that what is square root of minus 1? Not real. Is that okay?
Yes, sir.
In complex number, we know square root of minus 1 is iota I. Or we say I squared is negative 1. So we define another complex number I whose square is a negative,
Oh,
negative 1. So that helps us to solve this particular question. You understand now?
yes, sir.
So I've given you exposure to real numbers. So if your question is find the solution in the domain where x belongs to complex numbers, then you have two solutions. Do you see that?
Yes, sir.
Extremely important to know. Let
But,
us
sir, I
conclude
just.
at discriminant analysis, which is b squared minus 4ac, right? Now this
Yeah.
could be positive, this could be 0, and this could be negative. If it is positive, how many real solutions do you get?
You get two, sir?
If it is 0, you get 1. This is none. Is that okay?
0. Yes, sir.
So that is the end of this particular chapter. And you learn how do you find the second difference, how do you solve the equations, how do you graph the equations, how do you analyze the discriminant. Perfect?
Yeah.
So let me end this lesson and let us have your summary and learnings from this lesson. Tell me, Rohan, what did you learn in today's review on quadratic relations?
Well, sir, today in this quadratic relations review, I have learned about how to calculate with the formula and then being experienced, like doing my best to learn about what we may do in the higher grades when it came to learning equations which were cubed or even higher. For the finite difference, another thing was looking at if y is positive infinity, then x would be positive
And
infinity.
behavior. And
Yeah,
behavior.
and behavior, along with domain and range,
Yes.
as well
Increasing,
as
decreasing interval.
yeah, as well as looking at the discriminant, and then how we can calculate the non-real numbers if there's a negative exponent.
Complex numbers.
Yeah.
Correct. So you learned a lot today. That's good. It's a good foundation for your grade 11 MCR 3U curriculum. I wish you all the best for your final exams. Get 100%.
Okay.
Okay?
Thank you, sir.
Great. Thank you and
Okay.
all the best.
All right. Goodbye, sir.
Bye. You may join my classes by sending an email to the address given. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.